Okay, so looking at perpendicular distance from a line to a point. So again, this is a really, really common formula, and it comes up a lot in a lot of questions. It comes up in different chapters. We'll see it when we do circle and when we do things like that as well. So it's one to definitely kind of get your head around. You'll notice that we have in the formula, we've absolute value or modulus notation. So that's going to be important. That's making sure that distance always ends up being a positive value. The other thing that we need to notice as well is our equation of the line here has to be in the general form. So not in your slope-intercept form, you should rewrite it into that general form. So the two things we need are the point, x1, y1, and my line in that general form. The perpendicular distance then is the shortest distance between a point and a line. Okay, and that comes back to the idea that the shortest distance between 2 points is going to be a straight line. And then if it's between a point and a line, draw that a bit better. So if it's between a point and a line, the shortest distance will be the line that's perpendicular. So obviously that would be shorter than, say, that line there. So it comes back to kind of that idea, but it's important that you again have that in your head. If you're asked to find the shortest distance between a point and a line, that will be the perpendicular distance. So then in terms of using the formula, it's just a matter of subbing these values into our formula, making sure, I suppose, that we have, say, rewritten our line into the correct format and that we're subbing everything in correctly. So with this one here, I'm just going to rewrite that 8 and bring it over to the other side just to keep it in the exact form that I want. And then I'm filling in, so A is 3, x1 is 2, b is minus 4, y1 is minus 3, and c is minus 8, and it's over 3 squared plus minus 4 squared. And that should be absolute value. Okay, continuing on, 6 plus 12 minus 8 all over root 25. That's going to give me absolute value of 10 over 5, which is of course just 10 over 5, which is 2. So my answer for that one will be 2. So you can see it's just a matter of subbing everything into the formula correctly once you have it set up in that way. And in your log tables, the way the formula is written there is taken exactly from your log tables, so they will tell you that you need the point x1, y1, and that you need the line in this form. So they give you that information for you to work with. Looking then at finding the equation of a line if we're given the perpendicular distance between this line and some particular point. So the distance from 0, 0 to x plus y plus k is 4 root 2. Find the two possible values of k. So we should kind of know as well the two possible values. That's going to come out of the fact that we have the modulus. So with all our questions, when we have modulus, we tend to end up with two possible answers because we're taking that positive value of it. So we're given a point, we're given an equation of a line with a k that we don't know, but that's okay. We're just going to continue as if we do. So here, remember as well, it's ax plus by plus c equals 0. So a is 1, x1 is 0, b is 1, y1 is 0. C is going to be k all over a squared plus b squared, and the answer is 4 root 2. So let's tidy up this left hand side. So I just get the absolute value of k over the square root of 2 is equal to 4 root 2. I can multiply by that root 2 to get, and we'll just make sure that we do it correctly. So we get 8. So the absolute value of k is equal to 8. And what that means, of course, is that either k is equal to 8 or k is equal to minus 8. Those are my two options. So k can either be plus 8 or k can be minus 8. Those are my two answers. And we weren't asked to give the actual equation of the line, we were asked to just give the value of k. So if we'd been asked to give the equation of the line, we would need to write that out then at the end of our x plus y plus 8 and x plus y minus 8. Just making sure we're always answering the question, I suppose. So another part where this formula or using this comes up is when we're looking to see whether points lie on the same side of a line. And what we mean by that is if I have a particular line like this one here, and say I have 2 points A and B, I might want to know whether A and B are like this, where they're both on the same side, or whether maybe A is on one side and B is on the other side of the line. And what this comes down to actually is the sign of this perpendicular distance. So if 2 points lie on the same side, so if they're on the same side of the line, so say like A and C here, then what we'll have is the perpendicular distance from each point to the line. So this distance here, this green obviously different distances, but it will be of the same sign. So they will have the same sign. So the distance will be different, but they'll either both be positive or both be negative. If they're on opposite sides, then we end up with a situation where one of them might be positive and the other would be negative. So they'd be different, because it comes back to kind of again with this formula, when we're finding the distance, that absolute value will always make it positive, but in actuality, depending on the side of the line we're looking at, the answer could be positive or could be negative. It just depends. So in order to test this, in order to see whether points are on the same line, we're going to have to remove that modulus. And that again is coming back to what I said, the modulus will always make it positive, and we don't want the distance to necessarily be positive to look at this, because the only way we can know is if they're of different signs. So if we look at this one here, points, so example of whether points are on the same side of the line or not. So we're investigating whether A and B lie on the same side of the line. So let's set it out. If they're on the same side, then the perpendicular distance would be of the same sign. So if they're on the same side, then the perpendicular distance would be of the same sign. Rewriting my line as well, 4x minus 5y plus 6 equals 0. So let's sub into our formula. 4, we'll pick one of the points first, so maybe we'll do A first. 4 by minus 5 by minus 3 plus 6 all over the square root of 4 squared plus minus 5 squared. Okay, continuing on, and sorry, we're getting rid of the absolute value notation because we want to find out the actual value here. So minus 20 plus 15 plus 6 all over square root of 16 plus 25. Continuing on then, so 1 over 16 plus 25, so square root of 41. Okay, so 1 over the square root of 41, and then we're going to do the same thing then for point B. So looking at point B here, so again we're not using that absolute value notation because that will just give us the same sign regardless whether it's the case or not. 4 squared plus minus 5 squared, so 16 minus 20 plus 6, and we know that this is square root of 41. And tidying up a little bit, then we get 2 over root 41. Okay, so from that we have the same sign, so both of our answers are positive. So we can see here they're both positive, which means they have the same sign, which means they both lie on the same side of that particular line. Okay, if one of them had been negative, that would mean that they lie on different sides. But it's really important that we leave out the modulus notation here. So we have to leave out this modulus notation, otherwise we wouldn't be able to see whether it would be positive or negative, because that would remove the positive or negative part. Because you know from the bottom of the formula we're squaring there, so that will remove the negative also. So really this formula is kind of set up to not have negative answers because it's looking at distance. So we need to just get rid of that modulus notation to really see. So the perpendicular distance, I suppose, generally more than just answering questions like that of putting in the formula, it's really used in problem solving. So we might be given the distance between a given line and another parallel line. And if that's the case, we might have two possibilities for what that means. So looking at this diagram here, it's kind of giving us an example. So if I was told the equation of this green line, we'll call this maybe L. So if we're told the equation of this line L, and I'm told that there is another line that is parallel to L that is a distance of 3 units away, then what I could have is I could have this blue line, so it could be 3 units this way, but it could also be 3 units the other way from L. So I could be either side. So this is why it's important with these questions that you kind of take into consideration. And once again, we're getting two answers because we have a modulus. It comes back to the same idea again. Now, what's important with these questions is you need to make sure you're using that general form of the equation of a parallel line. So remember we said when we looked at the equation of a line that if I'm given one line that's in this form, if there's another line that's parallel, that first part will be the same and what would be different would be the last part, the k. So the ax plus by, because that's to do with the slope of the line, and parallel lines would have the same slope. So that ax plus by part would be the same on both lines that are parallel to each other, and what would be different would be the last number, the c or the k part. So that's what we have to kind of use or employ when we're answering these questions. So we're asked to find the equations of the lines which are parallel to 4x plus 3y plus 1 equals 0 and 2 units from it. So parallel to this line and 2 units away. So if we want to use perpendicular distance, if we want to use my perpendicular distance formula, we need a line and we need a point. Now we're trying to find the equation of a line. Okay, so let's let this be the unknown. So my line is going to be the thing that I'm looking for, the thing that I don't know, because that's what the question has asked me to find, is find the equations of two lines. That means then that we need to know the point. We have to find the point somehow. And how are we going to do that? Well, we're going to take a point on this line that we're given. So what we're thinking is we have a line, and this is, we'll call this L. So this is my line L. Okay, we know that there are two lines that are 2 units away from this line and that are parallel to it. And there's one on either side. And our formula will find us those two answers. We don't have to do anything crazy to go looking for two answers. The formula will solve those two answers for us. What we do need to take into consideration is just that we need to have, if we're going to use this as the equation of the line, we're going to use these black ones as my line, then what we need to do is we need to find a point on this red line. And we'll call this point maybe A, I suppose. We'll keep it simple. So we'll call this point A. So we want to find a point on that red line, and then we can use that in our formula. So let's say that A is when x is equal to 0. Okay, we'll say that A is when x is equal to 0, and let's sub that into our equation of the line. So x is 0, we don't know what y is, and I'm just trying to find any point on this line. Okay, I could have similarly picked any value for x or any value for y, but it's easier to just pick where x is 0 sometimes. So we get that when x is 0, y is minus 1 over 3. So this is going to be my point that I'm going to use, 0 minus a third. Okay, and that is somewhere on the line. So that's going to be this point here. Okay, and again, as I say, you could pick any point. You could pick x as 0, you could pick y as 0, you could pick x as 7. It doesn't matter so long as you're consistent, but it's sometimes nice to use where x is 0 because that's going to help us then in the formula later on as well. It just makes it a little bit easier for us. So what I have is as well, we have the missing line. So the missing line is going to be parallel to this line L that I have, which means this first part, this green part, is going to be the same. So it will be 4x plus 3y plus some k. We don't know what k is, but it'll be some k. Then I'm using my formula, so let me write that down. ax1 plus by1 plus c over square root of a squared plus b squared. And remembering as well, it's good practice just to write down your formula before you start, because it kind of shows that you know what you're doing, or it gives an idea of the path that you're trying to take with the question. So it shows that maybe even if you don't know fully how to solve it out, that you at least know that you should be using perpendicular distance. So it's always good habit to write them down. So 16 plus 9, and let's just tidy this up a little bit more. So I'm going to swap the k and the minus 1 around. So minus 1 plus k is the same as k minus 1. This is the square root of 25, which is just 5. So that's my perpendicular distance. And we know that the perpendicular distance is equal to 2. The answer is 2. So my perpendicular distance should be equal to 2. So tidying this up a little bit more, then we can multiply across by that 5, and we get that this k minus 1 part should be equal to 10. And this is an example again where we have our two methods that we could do. So if we go with method 1 first, I'll do both of them out because I know there are different people like different ones. We'll start with method 1, it's a bit easier. K minus 1 is equal to 10, or k minus 1 is equal to minus 10. That means that k is either equal to 11 or k is equal to minus 9. Okay, what that means for our lines then is 4x plus 3y plus 11 is equal to 0, and 4x plus 3y minus 9 is equal to 0. Okay, so we're ending up with those two values there. The other way that we could do it would be squaring both sides, okay, which is going to give us, of course, a quadratic. Okay, so we get a nice quadratic here. And again, we get the same idea. So k minus 11, k plus 9. We get that k is equal to 11, k is equal to minus 9, and I end up with the same two lines, as we should. Okay, they're two different methods, but they should be the same answer. They're just two different ways of doing the question. So these are my two lines that I've ended up with. And that's what we were asked to find, was the equations of the two lines that are parallel to this given line and 2 units from it. Okay, so those are the two equations of those two lines then. So making sure, I suppose, that we're happy with kind of where everything's come from there, that we're able to sub everything into our formula correctly. I suppose finding the point in the first place there can seem a bit odd, but it's making sure, I suppose, when we're using this formula, that if we're looking for equations of lines, let that be the line then. Don't try and use that to be the point. Find a point on the line that you have and use that as your point. So we look at two exam questions here. So the first exam question comes from 2004. And the first part says, calculate the perpendicular distance from this point, this given point, to another line. So fairly straightforward. So we're going to use our formula, ax1 plus by1 plus c over a squared plus b squared. So 3 by minus 1 plus, minus 4, minus 4 by minus 5 minus 2 over 3 squared plus minus 4 squared. You kind of notice that one comes up a lot. I like the 3 squared plus 4 squared because it gives you 16 plus 9, which adds up to 25, which has a nice square root. So they like going with that one. Fair enough. So 15, so absolute value of 15 over the square root of 25, which gives me 15 over 5, which is, of course, 3. So 3 units, I suppose, to be completely accurate. So a distance of 3 units. Now the point -1, -5 is equidistant from these two lines. And equidistance, if we kind of break down the word, equidistance, it means equal distance. So it means that this point is an equal distance between each of these 2 points. So if we want to find out what k is, we need to find the distance from this point to this first line, and then use that in answering with the second line. So let's find the distance between this point and this first line, which is actually the answer from the first part. So we know that the distance is 3 units. So let's set that up. Distance from -1 -5 to 3x minus 4y plus k is 3. So the distance is 3 units because that's the same line that we answered for in the first part. So again, setting it up, 3 by -1 minus 4 by -5 plus k, following the same idea that we did in the last part. We know that that was square root of 25, and we know that the answer is 3. So it's just 5. Square root of 25 is 5. Tidying this all up now, so -3 plus 20 plus k over 5 is equal to 3. K plus 17 is equal to 15. Then we, again, the same as we've always been doing, we have our two methods. So let's do them out. So method 1, k plus 17 is equal to 15, or k plus 17 is equal to -15. K is equal to, so 15 minus 17, which is -2. Or k could be equal to -15 minus 17, which is -32. Okay, method 2 then, I would default with method 1 because I think it's a bit it's definitely quicker. But again, you need to have just that happy understanding of how to kind of follow all of the parts of it. So if it's one that's confusing for you, then doing the kind of quadratic way might just be a bit easier, and that is okay as well. Just takes us a little bit longer. So 225, so k squared plus 34k 289 minus my 225, 64. Okay, so I want two numbers that will multiply to give me 64, not to give me 34. Now we have obviously the advantage here of already knowing what the answer is going to be. So let's have a look. So k plus 32 and k plus 2, which means that k is equal to minus 32 and k is equal to minus 2. And now we were asked to find the value of k, so we were, and we'll maybe just write out our possible answers for the line as well, just to cover ourselves. Now we weren't asked for it, so you couldn't really be marked down for not writing them out, but again, just good practice to really lay everything out. So we have two answers here, and I would highlight my answers for k also. Okay, so we'll look at another exam question. So this one's a bit more recent, the 2021 exam paper. And we're told the point ST is on this particular line. It's also a distance of 1 unit from another line. And we're asked to find the value of S and the corresponding value of T. So looking at this question, slightly different from some of the other ones. So this time it's the point that we don't know, and we kind of know the lines that we're working with. So we're going to set it up. We're going to kind of start it the way that I might expect that we would kind of start a question like this. And that's really following the same idea that we have. So we know that it's a distance of 1 unit from this point. So let's work with that. We'll use my line, and I'm using my point S and T. That's 4 squared plus 3 squared, and we know that the distance is 1 unit. So using that to kind of tidy up things, this is 5 from kind of what we've done before. We've seen that one coming up a few times. That's square root. So we get that this distance is going to be 5. Now we don't actually know how to solve a question like that with two unknowns. We've said before that with two unknowns that nearly suggests kind of simultaneous equations, something like that. All we can do is look back at the question and see what we haven't used, and that would be this first green part here, which is that the point is on this given line. So that means if I take my line, and if I sub in my values for x and y, I end up with something like this. And if I was to take that even further and maybe rewrite s in terms of t, well, now I have a way that I could sub back into this formula and remove s altogether and just have an equation in terms of t. So that's what we're going to do. So in here we'll write in 2t plus 8 plus my 3t plus my 6 that I have from the start and equal to 5. So 8t plus 32 plus 3t plus 6 is 5. So we get absolute value of 11t plus 38 is equal to 5. And now we've our two methods obviously for answering this. So first of all, I could say that 11t plus 38 is equal to 5, or 11t plus 38 is equal to minus 5. And that means then that 11t is equal to minus 33. So t is minus 43. So t will be minus 43 over 11, or 11t might be equal to, no, I was right the first time. Jump on the gun here, I was looking at the wrong one. Minus 43, so here t is minus 43 over 11, that makes sense. Here we're getting that 11t is equal to minus 33, which means that t is just minus 3. Now my other method, a bit more involved, is to do our quadratic, so square both sides. So 11t plus 38 squared equals 5 squared, so 121t squared plus 2836 t plus 38 squared 144 is equal to 25. So 121t squared plus 836t 1444 minus 25 is 1419. And what we'll do then is see, can we divide across by anything? And we can divide across by 11. Okay, so we can divide across by 11 there. So we could, at this point, I suppose, use our quadratic formula either to kind of speed this up for us. Now we have the luxury, I suppose, in this one of kind of knowing the answers that we're going towards. So we want two numbers that will multiply to give me 129, but that will add to give me 76. Or sorry, not 129. Multiply to give me 1419, but add to give me 76. So those two numbers will be 9, so 43 and 33. Now obviously we have the luxury of kind of already knowing those, so you could use your quadratic formula at this point, and that would be okay as well. That probably would just be easier to find them out that way. I'll have to just rearrange here as well to allow me to factorize a bit easier. So 11t plus 3 plus 43 t plus 3. So I get 11t plus 43 t plus 3 is equal to 0, which means that t is minus 43 over 11, or t is equal to minus 3. So same answer that we got the first way, and definitely for this one, the first way is a lot easier. It saves us an awful lot of time, and you can see how often we have to work with this modulus. So getting off that first method really saves you an awful lot of time, which can be really, really helpful. So now that we have t, we need to use what we know about s, which is that s is 2t plus 8. So s is 2 times minus 43 over 11 plus 8. And subbing that into our formula, we get that s is 2 over 11. So my point P could be 2 over 11 minus 43 over 11. Or s is 2 times minus 3 plus 8, which is going to be 2. So my point P could be 2 minus 3. And those are my two values. So kind of the key thing here, I suppose, across the board is making sure you're happy with that formula, first of all, that you're able to use that formula kind of fluently, that you know how to sub everything into it. This idea of using the general form of the equation of the line, particularly when we have kind of parallel lines. This whole thing about whether points lie on the same side of the line, obviously very important. And then a kind of side part of it as well is working with that modulus notation, so making sure you're happy with doing that and that you're able again to do that fairly fluently, and if possible using this first method is definitely the easier of the two, particularly when the questions get more complicated. But yeah, getting this perpendicular distance, getting comfortable and confident with that is really, really important and really, really useful then for later questions.